Okay, folks, so I'm just going to make a little video to go along with our lesson 10.1. Yesterday we talked about this a little bit in our Zoom meeting, but I just want to go back to the confidence intervals for a minute. So now we are trying to find the confidence interval for the difference between two population proportions. All right, so for confidence intervals, it's really important that we check for independence. So data should be collected using two independent random samples or a randomized experiment. Now that we are doing two samples, it's important that we state that it's two independent random samples, not just saying random sample, because they have to be independent of each other. And then when sampling without replacement, make sure we check the 10% condition. Like we talked about yesterday in our little Zoom meeting, make sure so that we can use the shape is approximately normal, that we check our large counts condition by doing the sample size times the p-hat for that sample size. And so pretty much it's like the sample size times the number, the proportion of successes, and then the sample size times the proportion of failures. And you do that for each sample. And we have to make sure they're all greater than or equal to 10. Okay, so in this problem, we want to construct and interpret a 90% confidence interval for the change in President Obama's approval rating. So when we do that, it's really important in the state part that you define your parameters. And again, like we talked about yesterday, make sure you say the true proportion or the population proportion, or you can put it together, the true population proportion for each one. You have to state the name of the interval, just like you have to state the name of the test. In this case, this is a two-sample Z interval for the difference in the population proportions. All right, so when we go from here, it would also be okay if you say it like the calculator does and say two proportion Z interval, because when you do it in the calculator, that's what you're going to have to use. Make sure that you state that they are two independent random samples. It's really, really important that the samples are independent of each other. The reason why we know these are independent from each other is because one was the approval rating in one year and one is the approval rating in a completely different year, so they have to be independent from each other. Also for the independent, because we are sampling from the population, we check our 10% condition. And then we make sure that we do our large counts to say that it's approximately normal. When you set up your do part, you just do your interval. So it's the difference in the p-hats, which would be that negative 0.03, and then plus or minus, and then you look up your z-star, your critical value there. And we're now using our formula for where we had to do the variance, and now it's the standard deviation or the standard error of your sample proportion. And these formulas are on your formula sheet, and we get the interval. All right, so one of the things I wanted to talk about is the technology piece to this. It is really important when you do these in your calculator that you use the two proportion Z interval and not the two sample Z interval. So I'm going to pull up the calculator and show you what I mean by that. All right, so when we come in here and we go into stat and then over to test, what happens is some students will pick this right here, that not two sample Z-test, going down to the intervals. Give me just a second, my computer's not working with me. Some people will think that they are supposed to do the two sample Z interval. So that this one right here, this number 9, but that is incorrect. If you do that, you are going to get the wrong answer. The reason why that does not work is when it's the two sample Z interval, that is the test for comparing means when the actual sigma is known, which we never know sigma, so we don't use it anyway. So I know that's confusing because that's the name of the test, but you will never use that in your calculator because we do not know the actual standard deviation of the population. So you come all the way down, and it's the two proportion Z interval. All right, something that's really important is when you type this in, the order you type it in does matter. So if you do like P1 minus P2, make sure you put it in that way, or vice versa. So in this case, because we did the population in 2010 minus the population in 2009, it's really important that I put my 2010 data first and my 2009 data second, because that is the order it's going to subtract in. So when we type that in, it's also very important that when you put in X1 and X2 that they are the number of successes. Sometimes when you try to figure out the number of successes when it gives you percentages, it doesn't give you whole numbers. You must make them into integers. One of my students last year got stuck on this part right here. She had one of these as a free response question on her test, and she couldn't get past it because she was not typing these in as whole numbers, and therefore it wouldn't calculate the interval for her. All right, so let's put these in real quick. We have 512. All right, and we put all our numbers in, and it's a 90% confidence level. So we go down to calculate, and it gives us the interval. It tells you, and of course the p hat 2, that was our um 2009, and it's not exactly 53%, but it's close enough. So don't stress about that. And then we can write down our interval. It is fine to do this in the calculator. Again, you technically do not have to write out all the work and show the formula like we've done here. But if you mess something up, you're not going to get full credit on the do part. So the suggestion is to, maybe if you, for time's sake, go ahead and just do it in your calculator. And then if you have time, come back and put all this. But if you do it in your calculator, make sure you write out all your information to the side so they know where you're getting that from. All right, and so for our conclusion, this part's really important. We are 90% confident that the interval from negative 0.066 to 0.006 captures the true change, or you could say the true difference, in the population proportion of U.S. adults who approve of President Obama's job performance from August 2009 to September 2010. Y'all, it's really, really important. You got your context here. Just learn that mantra. Therefore, it is plausible that his approval has fallen by 6.6% points or increased by 0.6% points. And then I love this part. Based on your interval, is there convincing evidence that Mr. Obama's job approval rating changed between 2009 and 2010? Since 0 is contained in the interval, it is plausible that there has been no change in the president's approval rating. Thus, we do not have convincing evidence that his approval rating changed during this time period. If 0 is in that interval, it could be possible that there is no change. All right, so this is for today's part of the lesson. When you are doing a significance test for the difference into population proportions, because the null hypothesis isn't for just one proportion, like, oh, we think that it is 20%. It's the difference between proportions. So the null hypothesis is always that the difference is that there is no difference. The difference is 0. So since the difference is 0, you can't use that P naught to figure out your parameter, what you assume to be true, for your standard error. So what we do is we do what's called the pooled or combined sample proportion. So to do that, you take the number of successes out of your sample 1 plus the number of successes out of sample 2, and you divide that by the sample size of 1 plus the sample size of 2. And this is also located on your formula sheet. So every time you do a significance test for the difference of two population proportions, you've got to find this pooled sample proportion or combined sample proportion. Now this part is the new part, and this is really important because this is not in your book. Your book does this differently. The new part is when you do the large counts condition, your book says that you're going to do N1 times P hat 1 like you did for the confidence intervals. That is no longer the case. Now, when you're doing a significance test, you're going to use the pooled or combined sample proportion for your large counts condition. So make sure that you've got that noted on your paper, and we fixed this yesterday in our video. Okay, so this is a document that is included in today's post. And this is for your book, because now the AP has changed the requirement for the large counts condition. Your book is a little bit different. So if you look in your book on page 621 and 622, this is what you need to replace with this. The book numbers here is different because this is from the 6th edition and we have the 5th edition, but it's the same thing as our book on page 621 and 622. So again, it defines what the combined or pooled sample proportion is. This is the same example as in the book. The difference is this part right here. And it's going to be different in your book, so making sure that you get this large counts part correctly. And then your book has a problem worked out on the next page, but they did the M1 times the P hat sub 1. So now you need to look at this example if you're looking in your book. When they do the large counts condition, you've actually got to use the combined sample proportion in that. So just use this instead of your book for that part. Okay, so let's move on and look at our problems. So this first problem is a significance test, and remember from what we talked about, make sure that you state the significance level. Make sure that you state your null and alternative hypothesis. Guys, for these, remember, the null is always going to be of equality. It should always be equal. Where the alternative might be that it's greater than, less than, or not equal to. Make sure your null and alternative hypothesis are in terms of the parameter. So they will be for P or for mu, not for X bar or for P hat. And you must define your parameters right here. This is where the context comes in. Make sure you say population proportion or true proportion. Make sure you have independent random samples. Do your large counts condition. And in this case, because we were sampling from the population, we needed to do the 10%. Because I had done this last year, I have my pooled sample proportion down here. You're probably going to want to start doing it earlier because you're going to need it for this plan part. And then I'm showing you actually where I'm calculating my z-score, but you can do this using technology. In this case, you will be doing a 2 proportion z test, where when you're doing a confidence interval, it's a 2 proportion z interval. Again, you will never be doing the 2 sample z interval. It'll be the 2 proportion z test or the 2 proportion z interval, depending on what you're doing. And in the end, since the p-value is approximately 0, and that is less than our significance level of 0.05, we reject the null hypothesis. We have convincing evidence that hearing loss has increased from this time period to this time period. Something that's really important in this one, we cannot show causation since it is not an experiment. This is just a sampling method, an observational study, not an actual experiment. Okay, where this last example is an actual experiment, and it's about smoking and the employees that quit smoking when they received a financial incentive versus when they did not. So when we do our conditions here, again, you're going to use that pooled or combined sample proportion. In this case, we did not need to check for the 10% condition because we are not sampling from the population. So for the independent part, just the random assignment allows us to view groups as independent from each other because they were either assigned in one group or the other. So you do it, you get your p-value. This little part over here is just a connection to earlier units where we, like if we organize the information from above, it kind of helps you to get your p-hats and your totals and all that good stuff. So we have our conclusion, just use the mantra. And then the scope of this, I love this part. Because subjects were volunteers, we can only conclude this result for this particular group. So notice when I write my conclusion, we have convincing evidence that financial incentives help employees to quit smoking. Now, we're talking about the employees at this particular company. We can't say that it would help, for all employees, no matter where it was. So if the data come from two groups in a randomized experiment, conclusions can be made about cause and effect. If the data comes from independent random samples, conclusions can be made about the populations from which the samples are selected. Be careful when you are using the back of the book to check your answers. If it is the part on the large counts condition, it's going to use the P sub 1 hat and the P sub 2 hat instead of the pooled or combined P hats. So if you have questions about that, we can always Zoom or talk about that. And I hope this helps, and we can meet about it later.